Welcome to engineers mindset. So let's say we are given to find partial z partial x and partial z partial y for the given function z equal to exponential xy sine 2y multiplying x squared sine xy. Okay, so as always, notice now that we have exponential xy sine 2y multiplying by what? Multiplying by x squared sine xy. So this is actually a multiple of two functions. What I will do is this. I will say let u be equal to the whole of this function, which is exponential xy sine 2y. Okay. And I will also say let v and v be equal to what? The whole of this function, which is simply x squared sine xy. So I have this. Okay, now since I've broken this equation to this, it now means that this actually implies that z itself is now, in place of this whole variable, I simply called it what? U. So z is now equal to u dot, and in place of this whole variable, I called it v. So it becomes u dot v. And it is obvious that this is actually what? Product differentiation. So I'm going to apply the product rule of partial derivative to actually differentiate this function. And from product rule, now let's say we want to find partial z partial x. Partial z partial x is simply equal to, so we said keep u constant, we have u, differentiate v partially with respect to what? X. Okay, plus now you keep v constant, so we have plus v, differentiating u now partially with respect to x. So that is the product rule. Now we know what u is. We said let u be equal to exponential xy sine 2y. So we know what u is. We also know what v is, which is this. So the only thing we need to do now is simply what? Find the value of what? Partial derivative of v with respect to x, and also find partial derivative of u with respect to x. That's all we need to do. All right, so let's try it now and see. Now from u, we said let u be equal to this. From u equal to exponential xy, okay, sine 2y, sine 2y. We have this. Also notice now that this is also what? A product of two functions. What we want to do now is actually what? Find partial derivative of u with respect to x from this function. So we want to differentiate u partially with respect to only x. But notice that this is also a product of two functions, exponential xy and sine 2y. So it's a product of two functions. So we can as well break it down also and use product rule to also solve for what? Partial u, partial x. So if we break it down, I will simply say let a, so take note, you can always use any alphabet that you want to. So you can say let a be equal to exponential x, y. We can say this, and let b be equal to the remaining variable, which is simply sine 2y. So I have this. So I've been able to now break this into two. I'm now going to have that this simply means that u itself is now what? Equal to, we said let exponential xy be called a. So this means, that means in place of exponential xy, I simply have a dot, and also we said let sine 2y be called b. So this simply becomes a dot b. So this is also what? A product function. So in order for me to differentiate u with respect to x, I'm simply going to apply the product rule for this derivative. Therefore, partial u partial x is now equal to, so from the product rule, you keep a constant, okay, differentiate b partially with respect to x, since I'm looking for partial u, partial x. So I will always differentiate all the functions with respect to x. So I will differentiate b with respect to x plus, now you keep b constant, differentiate a with respect to x. So that simply gives me b partial a all over partial x. So once again, I know what a is. I said let a be exponential xy. I also know what b is. Let b be simply what? Sine 2y. All I need to do now is simply what? Find the partial derivative of b with respect to x and partial derivative of what? A with respect to x. So let's start now and see. Let's start from when a is equal to exponential xy. Okay, from a, so from a equals exponential xy. Okay, the partial derivative of a with respect to x is equal to, now I did a video on shortcuts to differentiating exponential functions. Please, you may wish to want to look up the video to properly understand how to differentiate this from shortcut, because I'm going to apply a shortcut method to differentiate this. Now, I want to differentiate this variable exponential xy with respect to x. Okay, to differentiate an exponential function, all you need to do is simply differentiate the power, use that derivative that you've obtained now to multiply the exponential function itself. That becomes the derivative of that function. So simply what? Differentiate the power. We have exponential xy. So the power is simply what? Xy. This becomes the power of this exponential function. Differentiate this power. Use the value you obtain for this derivative to multiply the exponential function itself. So if I differentiate xy, recall that I'm differentiating a with respect to x only, not with respect to y. So which means if I differentiate xy here, xy now becomes the power. Now I want to differentiate only x, which means I said I'm going to keep y as what? Constant. If I differentiate only x, I will simply have what? 1. So which means the derivative of xy with respect to x is simply what? Y. So you have this. Use this derivative now to multiply back the exponential function. So I'll simply have y exponential x y. So that becomes the partial derivative of a with respect to x. Okay. Okay, so having known partial a, partial x, next is to find the partial derivative of b with respect to x. So, okay, so we now recall that b, we said let b be equal to sine 2y. All right. So from b equals sine 2y. Okay, so partial b, partial x is now equal to, so notice now that we do not have x in this expression. Since we do not have x in this expression, that means we are going to treat everything here as a constant, because I want to differentiate b with respect to x. Since there is no x in this expression, it means everything here is a constant, and the derivative of every constant is simply what? 0. So that means partial b, partial x is simply equal to 0. So we have this. So if we know partial a, partial x to be this, and we know partial b, partial x to be this, then we can now find the partial derivative of u with respect to x by simply employing what? The product rule. So if we do that, we have that partial u, partial x is now equal to, so we said keep a constant, and a is simply exponential xy. So we'll bring it down, exponential xy times, now differentiate b with respect to x, and partial derivative of b with respect to x gave us here as simply 0. So multiply by 0. Okay, plus next is what? You keep b constant, and b is simply sine 2y. So we have sine 2y. Okay, and then you differentiate a with respect to x, and partial derivative of a with respect to x simply gave us here to be what? Y exponential xy. So multiply this variable by simply y exponential xy. Okay, so this is times y exponential xy. Okay, so we'll have this. All right, so of course, you know now that exponential xy multiplies by 0 automatically becomes 0. So it means that this simply implies that partial derivative of u with respect to x is simply equal to y exponential xy sine 2y. Okay, so we have this. So this becomes the partial derivative of u with respect to x. So we've obtained this side of the equation, partial u, partial x. Next up now is to find partial v, partial x. That's the next thing we have to do. So from v, we said let v be equal to x squared sine xy. So let's now call that from v okay, equals x squared sine x y. Again, this is also what? A multiple of two functions. We have x squared multiplying sine xy. So I can also choose to say let a be equal to x squared and let b be equal to simply sine x, y. So if I have this, it means now that this simply implies that v itself is simply equal to what? In place of x squared, I called it a. So I have a dot, and in place of sine xy, I called it b, a dot b. So this is also what? A product of two functions, which means for me to differentiate v with respect to x, I have to apply what? The product rule. And from product rule, we know all I need to do now is simply what? Find the b, the x, and the a, the x. Okay, let's try it now and see. All right, so from a equals x squared. So from a here equals x squared, I will simply find partial derivative of a with respect to x. Of course, I only have x squared here, so which means I can actually differentiate this function. So partial a partial x will simply give me what? 2x. If I differentiate a with respect to x, I simply have 2x. Okay. Also from b equals sine xy, okay, that's here. From b equals sine xy, I want to find the partial derivative of b with respect to x. So please take note. Okay, so I also did a video on how to differentiate trigonometric functions by shortcuts. So please do well to look up the video to properly understand, because I'm also going to use a shortcut approach here to differentiate this. Okay, I want to differentiate b with respect to x, and I have this trig function sine xy. Now this is how you differentiate, since it's partial derivative. To differentiate a trig function, simply first of all differentiate the angle. After differentiating the angle, use the value of this derivative you obtain to multiply by the derivative of the trig function itself. Okay, here the angle is simply what? Xy. That's the angle in front of this trig function sine. And if I differentiate xy with respect to x, I have xy. I want to differentiate xy with respect to x. So it means I'm going to be keeping y as what? Constant. I don't need the derivative of y. Y is treated as constant, so keep it. I need to differentiate only x. And if I differentiate x, I will simply have what? 1. So it means if I differentiate xy, I'm going to simply have what? Y. Use this derivative now, y, to multiply the derivative of what? The trig function. If I differentiate sine, I will simply have cos. So that means this simply gives me cos. Then put back your angle x, y. So the derivative of b with respect to x simply gives me this y cos xy. Okay. All right. So now I know the b, the x. I know the a, the x. I can now substitute into the formula to find the value for what? Partial derivative of v with respect to x. Sorry guys, this is supposed to be partial v partial x. Okay. This is supposed to be partial v partial x, okay, which is this part of the equation. So I can now find the partial derivative of v with respect to x. So let's do it and see. Okay. All right. So partial v partial x is now equal to. So we simply said keep a constant, and we said let a be simply what? X squared. Then differentiate b with respect to x. So the b, the x simply gave us what? Y cos xy. So keep a is simply x squared. Okay, differentiate b with respect to x, we had y cos x y. Okay, plus now you keep b constant, and b, we say let b be simply what? Sine xy. Then differentiate a with respect to x. The a, the x gave us 2x. So keep a constant, and a is simply sine x y. Differentiate a with respect to x. That's simply what? 2x. Okay, so we have this. So which means the partial derivative of v with respect to x itself is now equal to Okay, so I have x squared y cos xy, okay, plus 2x sine xy. So this gives me the partial derivative of v with respect to x. Now, I know the partial derivative of v with respect to x. I know the partial derivative of u with respect to x, okay, here. So therefore, I can now find partial z, partial x simply by plugging the values into what? This equation. I know what u is, and I also know what v is, so I can now do that derivative. Let's try it now and see. All right, so partial z partial x is now equal to, so first of all, we said keep u constant, and we said let u be equal to exponential xy sine 2y. Okay, so partial z partial x is now equal to, so we said keep u constant, we said let u be exponential xy sine 2y, so u is simply exponential xy sine 2y, okay. This multiplies by the partial derivative of v with respect to x, and partial v partial x gave us this x squared y cos xy plus 2x sine xy. So we simply have x squared y cos xy plus 2x sine x y. So we have this, okay, that's the first part, u partial v partial x plus, now we go with v partial u partial x. We say keep v, and v, we say let v be equal to simply x squared sine xy. So keep v x squared sine xy, okay. Differentiate u with respect to x, and partial u partial x simply gave us y exponential xy sine 2y, okay. So we simply have times y exponential xy sine 2y, okay. All right, guys, so you may wish to leave your answer like this, or you may wish to want to expand the bracket, but I don't think anything will add if you expand the bracket. I don't think anything will add. Okay, this goes into this. We have sine 2y sine xy. This goes into this. Okay, so I don't think there's anything that will add here. So you may wish to leave your answer like this. That becomes the partial derivative of z with respect to x. Okay, so to find partial derivative of z with respect to y, this is simply partial z partial y. The order changes a little bit. You simply have this to be partial v partial y, and this to be partial v partial, okay, partial u partial y. So I think you can try this out yourself. Please do try it out, of course. Whatever you get, you can share to my number on WhatsApp. It's displaying on your screen. You can share it to me on WhatsApp, and then I will check it. I'll cross check it for you if you're in order, and I will give you feedback. All right, guys. I will see you in the next video with more questions on partial derivative. Thanks, guys, and cheers. Please, if you're new to the channel, don't forget to what? Hit the subscribe button. I'll see you in the next video. Thanks.